Hi guys, my name's Amy Nicholson. I'm a technical evangelist at Microsoft, and I wanted to chat to you today about something a little bit outside of the box for a Java conference, but I think totally relevant to developers nowadays, which is machine learning. So a really snazzy title there. I'm going to try and predict the future with machine learning, if any say that worked at the bookies or something like that. But so I'm going to talk a little bit, this is base level stuff. You don't need to know anything about machine learning at all. I'm going to explain sort of what I think machine learning is with a few examples. And then we're going to talk a bit about Azure machine learning, which is actually on Microsoft's cloud as a service. I'm going to show you how you can build a model from end to end really, really quickly and actually start consuming it into apps and websites and stuff like that. So I've got lots of demos to show you as well. So fingers crossed the demo gods are on my side. Okay, so I wanted to say first, so what is machine learning? It's a widely used term at the moment, but it's kind of widely misunderstood as well. Most people are like, oh, I have big data, therefore I must do machine learning. Or, here, look, I've got all this data, let's just throw it at a classifier and see what it does. Not the best way to approach it. So, what do we at Microsoft think of machine learning? Well, we think it's when computer systems become smarter with experience. So I promise you this is the only equation I'm going to be going through, no maths in this session. So what is experience? Well, experience is sort of past data plus human input. And what do I mean by that? Well, past data, we have so much data now coming out of devices, out of different services. People are storing data, weblogs and stuff like that, and then being like, so why are you storing that data? And they go, oh, I don't know, we don't really do anything with it. It's like, oh, guys, there's so much in there, so much to unlock. And data's also growing, exponentially every 18 months. We're doubling all the amounts of data in the world. So we should start, trying to learn patterns in this data. So that's the data part. Human input, interesting. That's more the machine learning side of it. So you have two forms of human input. It can be where, say, myself or you guys actually kind of get involved with the machine learning classifier. So you say, it gives you a prediction. You go, that's not really what I was looking for. Or you go, yeah, that was absolutely right. You've predicted it right. That was the answer. And then there's the other form of human input, which is where a human's not really involved. And actually the machine learning algorithm and classifier starts to tweak itself around the data and actually starts to learn for itself new patterns in data. I thought the best way to explain machine learning is to talk about a few examples of how it's used right now in some of the products we use. So first symbol on the left, kind of explosion thing, predictive maintenance. So we have a really great example of, I think they're called Thrice and Krupp. They're like a big lift company. You'll find them in some huge multi-story, massive skyscrapers. And they said, we want to be able to predict when things are going to fail before it actually happens so that we can have an engineer there with the right part to fix that lift as soon as possible. You think, well, that's better cost-wise, that's better customer satisfaction-wise. You can see how it all sort of reaps rewards. On the right there, we've got sort of a credit card. Credit card fraud and risk is massive in machine learning. How many times have people sort of left the country, you've got on a plane, gone to pay for something with your card, and then it's blocked it because it thinks it's unusual activity? That's machine learning. That's saying this is not what you normally spend or where you normally spend your money. Therefore, I think this is a risk. Someone might have stolen your card. The ones at the bottom are a bit more commercial. So you've got on the left a little shopping basket. Most online stores now have recommender systems. So you buy something and it actually starts to recommend other things that it thinks you might like. And that's often either learnt from your usage or from everyone's usage as well, sort of aggregated. If someone buys a laptop, they're probably going to want a laptop case, or they might want a mouse, or they might want something that's going to pair with it. And then finally, the sort of wavy hand. I couldn't really find a good symbol for this, but sort of Kinect sensors and cameras and things that recognize your body. That is totally machine learning anyway, understanding where different parts of your body are and how they move. But actually, Microsoft Research had a great story recently where people were able to come and do sign language in front of a Kinect camera, and then that was actually translated onto the computer. So if you think about, you talking to a dictaphone or something like that, well, this was the version for sort of people who use sign language, and they were able to sort of write emails using sign language. So that was a really cool, we've got lots of different aspects and different places that machine learning is being used. But you might ask the question sort of, well, why now? Machine learning's been around for ages. It's been in academia for years and years and years. And actually, a lot of the algorithms and classifiers that we use right now are really old. They've been done sort of way back with stats and maths kind of research. The reason it's more available to everyone now is because, well, the first icon, you've got the cloud, you've got the power of the cloud, so you're able to use the compute, you're able to use the storage for the data, and you're actually able to sort of, be able to use all that grunt rather than sort of a shaking sort of hot server sitting next to your data scientist. So this, that makes it more possible. The clock in the middle, agile. By using the cloud, we can actually train classifiers a lot quicker now. We don't have to wait days or months for things to train. It's being cut down to hours and even minutes, which is fantastic. And then finally, the sort of RSS, that's all the data. As I mentioned, it's doubling every 18 months, and we have so much data now that we actually need to start picking out the useful data and maybe pulling together different data sources to actually be able to infer different patterns in the data, which is always useful. And that results in machine learning, so available to everyone, and that's the whole point. So that was sort of what is machine learning. So I wanted to chat to you very quickly about what is Azure machine learning. So it's what I'm going to be demoing using today. So Azure machine learning is offered on the Azure Microsoft Cloud Platform. And it's a very simple solution. So you bring in your data, and that might be into either storage or into Hadoop. So our version is a HD Insight, where it pulls on the Hadoop big data and MapReduce. Or you might be able to pull it in from databases or even just upload the files if they're not too big. Once you've actually got the data there, you can use a fully integrated development environment. And it doesn't matter what OS you run in or anything. It's all you need is a modern browser, and you can kick straight off and start going with Azure Machine Learning, which is great. That's a whole UI. So you're clicking, you're dragging, you're building your models, and it's very interactive. Once you've built your model, one of the really interesting things about Azure Machine Learning is actually you can produce a web service, so an API. And all this is a simple REST API that you call and you can get JSON back. So, whereas before you might have had a data scientist, they're running Linux, they're writing in R, and they create these fantastic, really intelligent things, and then they pass it to a developer, and the developer goes, what on earth am I meant to do with this? You know what I mean? It's like, oh, gosh, I'm not sure what I'm doing here. Well, now that's not a problem. You can simply just call a REST API, which will then pull back your prediction. And that's why it's so great, and you can build it into applications and websites really easily. There's another option we've added recently as well. If people create models, you can actually start putting them into our Azure Marketplace, and you can either offer them for free, so people can use your predictions for free by giving you, requesting it with data, or you can actually start to monetize it. So if you think this is really useful and you can, make some money out of it almost, but if you think, people should be, paying a little bit every time they do a transaction, then you can absolutely do that. And I mentioned you don't have to actually develop on a certain operating system or in a certain IDE or anything. You also don't have to view your applications or wherever you consume that service on anything in particular. That can be on any device, tablet, phone. I'm not sure we can probably get it on IoT at the moment, but you never know. All the way up to sort of your Surface Hub and stuff like that. So massive screens. So that's a great thing as well. So really easy to use. So I actually wanted to sort of jump straight into demos. I think that's where you learn the most. So what I'm going to do is I'm going to jump into the Machine Learning Studio and actually build some models. I want to quickly talk through the scenario I'm going to do so everyone's on the same page. So our scenario is we're going to go from end to end. We're going to go from creation to publishing a web service, and we're going to try and predict if flights are delayed or not, given some flight data and some weather data. So we're joining two data sets together to try and infer something and predict something. We're actually going to use a form of supervised learning. So I mentioned, that human input. I said there was two different versions. Well, the one where we were involved, that's supervised. And the one where the machine learning classifier sort of tweaks itself, that's unsupervised. So we're going to do the one where we have the right answer and we can tell it how good it is. We're also going to use something called binary classification. So that's basically, classification is putting things into buckets. So sort of, zero, is this a 0, is this a 1, is this a 2? But we're going to use binary, so the answer is going to be yes or no. Is this flight delayed? Yes, or not delayed? No. And basically, we're just going to put all this together, build our model, produce it as a web service. And I've built a Java app that I hope is going to work. And I'm going to show you how easy it is to actually consume it, and we can get a prediction from it. OK, so we dive straight into it. OK, so some of you might recognize this. So this is actually the Microsoft Azure portal, where you can get lots and lots of different services. So if you look down the left side, you've got your websites, your virtual machines. Some people might recognize the Hadoop little elephant there, Visual Studio Online. What we're actually going to do is we're going to scroll down, and you'll notice there's a machine learning sort of little canonical glass. If we click on that as a service, you notice I come onto this screen. I have lots of things going on in here. These are called workspaces, and I would often say a workspace is almost like a folder on a file system. So I've got, for example, a Twitter one here. I don't know if anyone saw, I did a digit recognition demo that I've got all my experiments in there for. What we're actually going to use is the flight delay lab. And all you simply do is click sign into Machine Learning Studio here, and it actually takes you to this environment. You'll know you've actually changed tabs because it said Microsoft Azure Machine Learning at the top, and you've got a slightly different layout, but it's a very recognizable environment. So on your left, you've got experiments, web services, data sets, etc. In the middle, we've got a list of all the different experiments I've got going on in this one. And then on the right, you get a little preview, just so you know, which experiment's this again, and you can kind of look back. You'll also notice we're in the studio at the top here. The home button has lots of sort of introductory resources, so if you guys go away and you want to give it a go, there's lots of videos and documentation and help on there, so do check that out. I actually want to show you guys the gallery. It's in preview. It got released sort of a few months back now, and basically what this is a place for everyone to sort of as a community contribute all their different experiments. So you'll notice there, these are some of the top trending experiments. Let me go back there. And basically, you've got customer churn. The wine classification one, always up there. I don't know how important people find it is to predict their wine quality, but that one's always up there, which is great. But if I actually browse here, I'm looking for a specific one. So if I type in UK, these ones are made by myself, Amy Nicholson. So if you fancy looking up and seeing the demo we've done today, you can just type in UK and I can actually click on this experiment. So what I've done is I've built a model, and I've said, I want to share this with the community. I want people to be able to take it down and have a look around it and stuff like that. So I've got a little bit of explanation. If I click Open in Studio, what it'll do is it'll take sort of a carbon copy of my experiment and actually ask me if I want to put it into here. So I want to use this workspace. It's going to think about it, and hopefully it will open the new experiment in a sort of copy. And all you need to do at that point is just click Run at the bottom. And I'll start explaining this layout. OK, so this is the initial part of the experiment. I've done a lot of the pre-processing. In machine learning, it's really important to have done a lot of the pre-processing of your data. Machine learning really doesn't like missing values. It likes data in a certain format that it can learn from. So, joining these data sets I've done here. I've removed some missing values. I've also, if I zoom in a little bit there. I've applied some math operations to make sure the timestamps are the same so we can join them. And just simple things like that. I mean, you can do it in Azure Machine Learning. I wouldn't always recommend it. Use the tools that you're really good at using, to hack around with your data, and then bring it into the studio and start doing some machine learning, because the key to this product is the machine learning and the web service part of it. That's where it's really, really intelligent. OK, so that's finished running, which is great. So at the bottom here, what I can do, each of these modules, it sort of does something. It's like a transaction almost. And when you click on them, it often has properties. On the left is where you pull all these different modules from. So you notice this sort of data input-output. We have our whole machine learning classifiers here. And you can also sort of get data transformation and feature selection tools. So what we're going to do is we're going to start building. We've got our data. So if I right-click and visualize, at the bottom of every module, you can actually see a snapshot of your data. So every time you do a transformation, you can see whether it did what you expected it to do. So, I mean, this is, I mean, it's not a trivial set of data here. We've got 2.5 million rows nearly of data, and it's running pretty quickly. You know, like I said, this is really agile development. We need to be able to quickly iterate on it and build great models. And we've got 16 different columns. Some of them tell us a little bit about the airport, and then others tell us a bit about the weather, and that's where we're going to learn some detail from. If I just show you one more column that's useful. So this column here, that's our label. That's what we're trying to predict. We're trying to predict whether a flight is delayed or not. If it's a 0, it's not delayed. If it's a 1, it is delayed. So that's the key to remember. But what we need to do is we need to tell the studio that that is the label we want to actually look for. We want it to learn from that. So we need to add some metadata. You've got a little search box up here. So once you get to know the studio, you can actually start just searching for the modules. It's certainly my best friend. I spend a lot of time here. So all you have to do is click and drag it onto the screen and then actually just connect it like a flow diagram. So from there, it will then go, oh, there's a little red mark here. I need to set some properties. So if I wander over here, what I want to do is I want to tell it that arrival delay 15 column is my label. So I'll begin with no columns and include the column name, arrival delay 15. And what I don't want to change its data type. It doesn't need to be categorical, but under fields, I want to tell it it's a label. Then if I drag on another one, another word in machine learning is actually features. So features are something that it learns patterns from. So if I tell this studio that there's a feature here, it will say, okay, great, I'll look at that piece of data. And then I say there's another one here. It'll go, okay, for that label, when these two data values move, why does that change? Why does that label change? And it'll find all those patterns. So here, all I can do is, if I begin with all columns and actually exclude the label I just set, then it's basically saying the rest of the data set are our features, and I want you to learn from all that data. So at this point, we've got some metadata. And then there's something else quite important in machine learning, and that's actually to split your data into training and testing sets. So if I connect that one, when I say training and testing, the training data set is where you want the majority of your data to go. So if I put 70% in there, that'll say that 70% comes out this left sort of port and 30% comes out the right. Training data is what we pass to a classifier. So you guys, I don't know if you guys have heard sort of neural networks or logistic regression and stuff like that. They're quite well-known ones. And what you do is you pass a classifier some data, and you say, take both of them, learn some patterns, and then come back to me with a prediction. We hold that 30% back. So we hold that and we say, we don't want to trust you completely to get it right first time. So what we'll do is we'll say, I have this label. I know if I've got the right answer. So what I'll do is I'll give it previously unseen data, and what it will pass me back is a prediction, and all I then have to do is to look to see if this value is the same as this value. And then it's just simple math calculation. So what we'll do now is we'll actually look for a machine learning classifier. So if we go down to the machine learning column, you'll notice I said there was sort of classification, anomaly detection is an interesting form of machine learning, clustering and regression. We're doing classification, yes or no, and we want a 2-class one. So for binary, so if I just smooth that over a bit, I'm going to use a 2, is it this one? No. 2-class boosted decision tree. You'll notice when I drag this on, I get a lot of properties. Now, I've gone and set most of these properties with the other modules. Fortunately for us, Microsoft Research have provided all of the classifiers we give you with some sort of default parameter values that will work quite well with most data. There's also a great module called Sweep Parameters, and that's able to then take your data and your classifier and say, what are the best values you could set there to actually get a really good, accurate classifier? So again, we're helping you out, we're helping you get involved and actually build some really intelligent models. So I mentioned that we had training data. Well, now what we want to do is we actually want to pass the untrained classifier here into the train module, and we want to pass the training data. So we're saying, like I said, classifier, some data, and we're saying go away and learn all the patterns in there. But I just need to remember to tell it what it's looking for. So if I include, and then I can just select all labels because we chose that metadata, which is really handy. Next, I said we sort of hold back that 30%. Well, with that, what we want to do then is we want to say, okay, you think you've learned some really good patterns here. We want to attach I don't know if you guys can see it. So it says trained model instead of untrained model now. So if I pass that into the score model, and I also pass in the testing data, so that 30%, where we have the right answer, and we're asking it, is it getting the right prediction? I don't need to set any parameters there because it's a simple yes or no summation. And then finally, we want evaluate. And this is just going to give us some statistics and a nice graph about how well our classifier is doing. So if I connect that. You'll notice with most of the other modules, I've always connected two things to it if there's been the option to. With the evaluate module, what the great thing is, I can actually compare classifiers directly. So what I can do here is I could bring on a neural network on this side, and I can hook them both up and see them both on the same graph. Now, if you think of that in if you were to do that in code, that's a lot harder. There's a lot more code you've got to write there, and this kind of brings it all together, copy and paste, and you're running with two classifiers. So if I click run there, that's going to go through and build a model. So technically, in 6 to 8 different drags and drops and a few properties to set, we've created a binary classification model using a boosted decision tree, and we're going to try and predict if a flight's going to be delayed or not. So, I mean, it's not too bad, and I've got my timer going here. We're okay on time. So it's running through this. You'll notice it says running at the top. Also, don't panic too much, because when it says running, some people go, oh, God, it's going all the way from the top again. It's not. It does cache data. So when it's going right from the top, it's just saying, is this module the same? Is the data here the same? And if it is, it will just skip on to the next one. So if you've just added something at the bottom, then it will just process that, which is great. So now I've got a model. We want to just have a look at how good it was. So if I right-click and visualize here, it will come up with some results. This is actually an ROC curve. I think it's like receiver operating characteristic, which means nothing to most people. So basically, if I explain it really simply, you've got a sort of grey line in the middle. That's kind of 50-50. Your classifier is just going, oh, I'm just going to throw out a 1, then I'm just going to throw out a 0, and there's no real intelligence behind it. The closer the curve is to 1, the better. However, if you have a curve that's sort of a sort of right angle, that's really bad, because there's something wrong there. You've got something in the data set that's giving away the answer. You've got something that's highly correlated. And in a real life situation, you're probably unlikely to have that piece of data. So, and that's actually called overfitting, if people want to go and look into that a bit more. If I scroll down here, we also get a few numbers, which is handy. So this is a demo, so it's 92% accurate. I'm not just like amazing at machine learning or anything. It's some good data in there. But basically, this will tell you accuracy. A good amount of accuracy is actually sort of 75%. Like I said, if you're getting too close to 1, you might have a bit of a problem. And then you get precision and recall. So in certain scenarios, it might be important to have absolute precision. So, I mean, it's kind of a bit uncomfortable to talk about. When people are ill and you kind of trying to diagnose them, you wouldn't want to miss someone who is ill, and you also wouldn't want to tell someone they're ill if they're not. So the precision's got to be really, really high on that one. But there's also an option to sort of set a threshold. So if the classifier isn't sort of 80% confident, 90% confident, you can say, just dismiss this and let a human sort of intervene at that point. So that's a really handy sort of way of doing it. And then you've got your sort of true, positive, false, negative matrix there. So it tells you which buckets they fall into. So the majority fall in the right place, but sometimes we're saying the flight is late and it's not, and sometimes the flight is late and we're saying it's not going to be. So that's a pretty decent model. So if I wanted to actually start making that into a web service, what I can do now is click train model and go create a scoring experiment. And what this is going to do is actually going to sort of pull together all my different modules and just, oh dear, that obviously wasn't meant to happen. So it's okay, because it's like Blue Peter, so I've got one I prepared earlier. So if I just go to this one. So if I actually click into here and zoom in a bit more, you'll notice this is exactly the same experiment. We've built our classifier, but you'll notice sort of metadata has disappeared, the split of data has disappeared, and what happened is it's actually pulled it all into here. So it's like sort of merged them all together, and it said, right, now this module is available to any experiment that you produce in this workspace, so you can keep building different experiments with the same model. and then that has all the intelligence. So that's your classifier plus your domain data with the accuracy that you had sort of going forwards. You'll also notice if I click this tab up here that we can go straight back to the training experiment we had earlier. So if we zoom in there, you notice that's exactly what we had earlier. So it just gives you in another tab. Right at the start, when Azure Machine Learning was created, you used to have to sort of start deleting things, and that just feels unnatural when you've just built it. So you're like, oh no, I don't want to start deleting things. What if I can't get it to work again? So this is a much better version. You have these two sort of side by side. You also notice that there's a few extra things that it adds on as you create an experiment. And if I click this little switch here, this is actually where the web service starts to interact. So it's put in a web service input, and it's also put in a web service output. So this is, if you think of the web service input, this is the path that your user will take. So it will come in through the web service input, it will go into the score model, it will pass that data to the classifier, make a prediction, and then pass it to the output. So, really simple diagram showing how it passes all the data about and gets the prediction. Once you've actually got that, there's only one little caveat that you need to remember when you're actually creating one. So if I switch back to the experiment view, is this project columns module. Currently, in the other one, we had that label, we had the right answer. We knew whether that flight was delayed or not. In real life, we're not going to know whether the flight's delayed or not, so we don't want to ask our user for it. Therefore, what we're going to do is actually just exclude that label. So we're going to take it out and say, okay, we don't want to ask our user for it, we need to predict it. And then from there, all you need to do is actually just create a web service. So that's all run. If I click publish web service, what I'll do is go away, and it'll actually create us a web API page. And it'll give us sort of different options of how we choose to sort of request our API. So here we go. So it's got the name of the experiment at the top, so you know what it is. You've got your API key. You've also got the option to request response or batch execution. So if I click on this one here, you'll notice this is just a sort of generic API help page for request response. So you've got your sample requests. You notice this is all the data that I've built my model on. So I haven't got to come and edit any of this and build it. It's all been built for us. There's also a really great bit at the bottom that actually it's got some sample code. Currently, it's in C#, Python, and R. I'm sure they'll keep adding, just like they do all over Azure, with different languages. And you can simply just click select sample code, copy, paste it into a new class in your project, in your application, and start calling it from there as a REST API. The only caveat is to remember, like I said, it's all personalized to your model. The only thing is, please do remember to replace your API key. Obviously, this is just a web page, so someone could come and scrape it, so we don't put your API key in there. So you just need to get that from the actual main page. So that's it. We've gone from creation, we've built a model. Normally you would iterate on it and improve it, and then we've actually created a web service. So if I now, this is the key part, it's the bit I'm worried about. So basically, I've gone into my documents. What have I got? I've got in here a test file. And in here, I've just got a simple jar, executable jar file, and I've also got a little properties file. So if I call that jar file, so it says it's submitting some arguments to this carrier is Delta, so Delta Airlines. It's calling off to my REST API, and it's going to come back to me with a prediction. So it says this flight will be delayed, and its confidence score on it is 0.994. So it's like pretty sure that this flight's going to be delayed. So bad news, Delta Airlines. But if I go in and actually change some of the... So this has just got my endpoint, my API key, and then a few properties. So you can think, this would be maybe built into a form in your app or into your website or something like that. You pull in the data, and someone tweaks it. So if I change the airlines, say American Airlines, it's actually an American data set. So if I call it again, now it's calling carrier AA. It says it will be delayed again because of the other values, but it's by 0.996. So this classifier has obviously found some patterns where American Airlines might be more delayed than Delta Airlines. I'm not sure if that's true, but who knows. So that was basically just calling it from a Java app. So that was simply, if I open IntelliJ, we can't really see the code here, but we've got a prediction request, we've got a file path, and we're just simply pulling in the new data. We're passing it off to the call, which is just here, get the properties, we're getting a class, we're getting a file loader, and then we're just pulling together and we're actually just hacking about with a JSON to actually display it. That's simply all it is, which is great. So there, we've gone from end to end, and we've got some data, we've gone through our scenario, we've got a web service, we've built it into an app, we've called it, and it's actually given us back a prediction. So that's, it's quite simple really, which is great. So I've got a little helpful resource. I think I'm actually probably tweeting out about it around about now. So this is a Microsoft Azure machine learning cheat sheet for algorithms. So I picked a boosted decision tree. Why did I pick a boosted decision tree? This is a really handy sort of flow diagram, and it asks you a lot about your data. So it'll ask you, what's in your data, what are you trying to predict, and then it'll tell you whether it's a classification or a regression problem. It'll also tell you kind of what classifiers you want to use, whether you want to use a really powerful neural network, or maybe you have an interest in data distribution and you need to use a different type of classifier. So my Twitter handle, is Amy Kate Nico. I've probably just tweeted about it now. I wonder how I did that. So I want to show you one more thing. What we have is something called machine learning APIs that Microsoft have made. I don't know if anyone used howold.net. Did anyone use this website, took a selfie, told you what your gender and age was? Yes, brilliant, nice one. Obviously, yeah, great stuff. Well done. No one else did, apparently. Well, actually, there was 236 million images submitted to this website over a course of about 2 months, and it went crazy on Twitter. This was actually just built for a keynote at the Build Developer Conference. Day 2, they didn't really expect that many people to use it, I don't think, and actually it just went crazy, and people were trying to find, putting all sorts of different images in. I think someone tried to take a picture of a leak, and it actually said, we cannot say whether this is how old this leak is, which is quite good fun. So I put myself into it. This was me on a better hair day than today. It said I was female, so that's great, and it said I was 24. Well, I'm actually 23, but I'm 24 in December, so fair enough. Some people got heavily insulted, one way or the other, but it's all a bit of fun. And the main story behind this is really the machine learning APIs. So what was built with this one is this one called a face API. And what it can do is it can actually do gender and age. And it can also do, is this person in this picture the same as the person in this picture? And it can cluster pictures into family groups and stuff like that. So there's lots of different things that each API can do. And the gallery we went to and we got the UK experiment? They're on the top line there, and you can just go and look at all the different ones that are available. So you've got image recognition, you've got text analytics, you've got natural language processing, there is all sorts in there. So if you want one that's sort of pre-built and you just want to be able to call it, this is a fantastic place to look. So I actually have a demo that I want to show you. It's an Office app, so we've built it in Visual. Oh, sorry. Let me share my screen again. Great stuff. So I've got Visual Studio open here. It's just a simple, it's actually an Office app project. So in Office now, you can get sort of a banner down the side. You might have seen a Wikipedia one or a dictionary one. A gentleman helped me on our team to build an Office 365 app. And what it does is it calls the text analytics machine learning API, and what I can get back from it is sentiment and also keyword extraction. So he built it into it. It's called Sentimental. You can get it in the Windows Store, and you can also get it on GitHub, so I'll share that link with you guys. It's a simple HTML JavaScript project, nothing too complex here. He's got sort of the HTML or how it's laid out, but it's mainly in the JavaScript I want to show you. So if we go right to the top, it's a simple JavaScript file. We're just calling in different functions. If I zoom down a little bit here, this is a good one. So this gets the sentiment analysis data, and literally all we pass it is our authorization key. We ask for our data back in JSON, and we call the API URL. So you notice this goes to the datamarket.azure.com. It's the text analytics API, and we want to get the sentiment. That's the function we want to call. And all you literally have to do is just append your text on the end of that URL. It'll call off with your text, and it'll bring back a JSON query that you just need to pick apart. So you do all your checking it's all valid and your request headers. You say it's get with JSON. And then finally, we start to say, OK, so if the sentiment of a sentence is bad, we're going to put it in sort of dark orange, red. And if it's good, we're going to put it in green. And if we're not sure, we're going to put it in orange. So he's done lots of hacking around with the code there. So if we run it, it's going to open Word for us. Just going to close that. And you notice this is the app on the side. So simple HTML, JavaScript here. So if I type in the DevOps conference is amazing for Java devs. And then what I can do is I can simply highlight this, click Analyze. It's going to go away. So it says this is positive. It is a positive sentence. And it's also picked out some key phrases. So it's picked out Java devs and it's picked out DevOps conference. So that's really handy. I mean, if you're thinking about where you could use this, you could use this if you had sort of event feedback. DevOps guys, if you want to borrow this, that's great, no problem. You want to do some event feedback when you get textual feedback. Really quick way to just sort of sift through. If you had any that wasn't sure about, you can go back and look at them. But it's a much smaller amount of feedback that you can look through. He's also sort of inserted certain things, so I can click here, insert key phrases, and it pops it below it and stuff like that. But again, I just kind of want to show you how easy it is to just call a REST API and actually get all this intelligence straight into one of your apps, which is great. So I've actually gone through this quite fast. This is brilliant. I thought I was going to be rushing at the end. So if I just stop that there. So yeah, do go and check out those APIs. They're really great. There's lots of different ones on there. Originally, it was just sort of facial recognition and text analytics. Now they've got all sorts. They've got sort of customer churn scenarios and predictive maintenance we talked about with the lifts. And so yeah, do go and check them out. They do awesome, some fantastic things, which is great. So I thought I'd say, what do you guys want to take away from this? So I've shown you some cool demos. I've shown you how we create a model, how we consume a model, how this can be built into all sorts of different places. So first thing I'd say, go and explore the Azure Machine Learning Studio. It's great fun to get in there, start clicking about, and just see what you can create. And also check out those APIs. Like I said, they're really useful. Start building some intelligence into your applications. If you already have one, you think, actually, I could do with some text analytics maybe, or I have something where it pulls in an image and I want to compare two different images. Have a look through them. There's lots of different stuff in there that you could build in, and it's just a simple REST API. And then finally, machine learning is often only one part of a solution. So we've talked about sort of one small part. If you think of it in an IoT scenario, you might want to bring in some data from a device. You might want to sort of aggregate over that data, do a bit of data processing. You might want to call a prediction API, get a prediction back, and then pass it to, a visualization tool and actually view your data in real time, moving. I mean, it comes as a small part. It's not always the be-all and end-all. It's where you actually visualize it. It's where you consume the data. And there's some really fantastic data services on Azure that can sort of collaborate with it, which is great. So do go and check those out. So that's mainly what I had sort of planned to chat to you guys today. That's my Twitter handle. Please do follow me. I always tweet about stuff like this and IoT and machine learning and data. So if it's something you're interested in getting into, then do follow that hashtag. I've also got some useful links on the side here. Where to sign up. If you want to go and sign up for Azure and check it out, see whether it's something you would like to use, you can actually get free credits for a month to use. You can pretty much use all the services for a month, see which ones you want to use, be that websites, be that machine learning, and then you can sort of decide from there whether you want to carry on. There's also a link to the studio and the gallery. So the studio was where we built the model, and the gallery was where we were picking those sort of example experiments. The gallery is a great place to start, just to see what other people are building. But if you do build something, please do contribute it. It's like a sort of community kind of thing. The more intelligence and the more models we get in there, the better. And also there's a OneDrive link there. I do lots of stuff with this, so I've got lots of different demos, and also sort of step-by-step guides. So the experiment we walked through today, I have really run through it ever so quickly. I can normally do that in sort of a day workshop session. So do check out there. It's got a full document. You can follow it through, understand it a bit more. There's also some great videos on there of demos, and also really useful links that you might want to have a look into. So yeah, I think that's all for me. Does anyone have any questions? I don't know if people are people using that link at all and texting in the questions? Maybe I'll check if it's... But yeah, thank you very much. And if you need any more details, please do come and find me, or if anyone wants to ask any questions. Thank you.